Hello everyone, this is our first topic in electrical fundamentals and we are going to learn the basic concepts to analyze a circuit. You know that when we connect a battery to a bulb, the bulb will light up. So the battery is supplying a voltage and the current is moving through the bulb and the bulb will light up. So there are two flows here. We have electron current flow where the electrons are moving from the negative side of the battery and it is coming back to the positive side. But when we consider the conventional current, it is opposite to the electron movement. So you can see here the conventional current is starting from the positive side of the battery and it is moving to the other side. So when we consider the current, we consider this conventional current flow. So here we have the diagram for a circuit. So normally battery, we are using this symbol for the battery. There are other symbols that we are going to use and I will explain you when we come to that stage. And the resistor bulb is a resistor. So resistor, we are using this zigzag sign for the resistor and you can see the current flow is flowing from the positive side of the battery where you have a longer line and it is moving through the resistor and coming back to the battery. So here there are basic three things that we need to know: the voltage, the resistance and the current. So the battery is supplying a voltage, bulb is a resistance, and the current is coming from the voltage source and moving back to the voltage source, going through the bulb or going through the resistance. So we will learn more about these three elements and we will learn about their relationships. So voltage, resistance and the current, how they are related with each other. First start with the current. The current is the rate of flow of charges. That means the rate of flow of electrons, and we can use I as the abbreviation for the current, and Q is the charge and the simple T is the time. So I is equals to dQ over dt, and current is measured in amps and the charge is measured in coulombs. The time is measured in seconds. Let's do a small example to get familiarized with the previous equation. A conductor has a constant current of 5 amps, so they have given us the I. How many electrons passes a fixed point on a conductor in 1 minute? So the time also given to us. The time is 1 minute, but in the previous equation we have to substitute the time in seconds, so the time should be 60 seconds. And they are asking us to find the number of electrons. And they have given us the charge of an electron, 1.602 times 10 to the negative 19 coulombs. So let's use the previous equation. Q over T is equals to the I. And if we can find the Q, we will be the charge, we will be able to find the number of electrons. So let's make the Q the subject. So Q is equals to I times T. I is 5 amps and T is 60 seconds. So the charge in coulombs is 5 times 60, which is 300 coulombs. Now to find the number of electrons. One electron is 1.602 times 10 to the negative 19 coulombs. So to find the number of electrons, we have to divide this total coulombs by the charge of one electron. So it is 1.06. So it's 1.602 times 10 to the negative 19. So if we solve this one, we get the answer. So let's see the answer. So that is 1.87 times 10 to the 21 number of electrons within that 1 minute or within that 60 seconds. When we look at the current can be direct current or either alternating current. Direct current means the magnitude and the direction of current is not changing with the time, so you can see a straight line. So the batteries that we have, they are DC, supplying a DC current. Alternating current is the current which is changing with the time. It can be magnitude or it can be the direction or it can be both. So the current that we get from the wall socket is alternating current. So we can convert the alternating current to direct current by using equipment. So we will learn those things at the end of the course. So alternating current can only be the change of the direction as well. So this is an example of a sinusoidal alternating current, and also we can have something like this also we considered as alternating, because even the magnitude doesn't change, it changes the direction. So it can be either the direction or the magnitude, or else both. So we will learn about the direct current and alternating current in coming weeks. Now let's look at the voltage or the potential difference. A voltage is the energy required to move one unit charge. So energy divided by the charges in Coulomb, that will give us the voltage. So if you look at the units for this, voltage is measured in volts, energy is measured in joules, and the charges measured in coulombs. So we have already discussed about the current and voltage, and the third terminology that we are going to discuss here is the resistance. A resistor is a circuit element that dissipates electrical energy, usually as heat. So in this circuit, the bulb is the resistance. So resistance is equals to the voltage divided by the current. Resistance is measured in ohms, and we use this symbol for ohms. And as we already know, voltage is measured in volts, and also the current is measured in amps. One of the basic laws that we use in electrical engineering is Ohm's law. It says voltage across the resistor is directly proportional to the current flowing through the resistor. So if you consider the voltage, it is proportional to the current. So we can take out this proportional sign by adding a constant, which is the resistance here. So Ohm's law says voltage is equals to the current times the resistance. So here we can have two extreme possible values for resistance. Resistance can be 0. When the resistance is 0, we say the circuit is short circuit, and when the resistance is infinite, then we call the circuit is open circuit. We will learn this more in our coming slides. Let's do a small example to use the Ohm's law. 120 volt battery is connected across a resistor and causes a current of 6 milliamps. Determine the resistance of the resistor. If the voltage is now reduced to 50 volts, what will be the new value of the current flowing? So in the previous one, I forgotten to tell you, voltage is equals to current times the resistance. In this equation, actually, we need to have the voltage in volts, current in amps, and the resistance in ohms. So here the current is given to us in milliamps, so we need to make it to amps by multiplying with negative 10 to the negative 3. Here the voltage is given in volts, so we are fine with that. So we are going to use the Ohm's law, which is V is equals to IR. They are asking us to find the resistance, so the resistance is equals to voltage divided by the current. So voltage is given to us, which is 120. We divide that by 6 times 10 to the negative 3. So we get the resistance. Let me check the number. 120 divided by 6. So it is 20K, or else we can say 20 kilo ohms. And in the second part, they are asking us to find, they are saying the voltage now reduced to 50 volts. What will be the new value of the current? So here we have a voltage. So this is a symbol for the voltage supply. I will discuss this in coming slides. So here we have 50 now, and the resistance is not changing, so it is 20 times 10 to the 3 ohms. And now they are asking about the new current. So that current, if we rearrange the Ohm's law, current is the voltage divided by the resistance. So voltage is now 50, and the resistance is 20 times 10 to the 3. So we can find the current, which is 50 divided by 20, which is 2.5 times 10 to the negative 3 amps, or else we can say it as 2.5 milliamps. So the current for the second question, it is 2.5 milliamps. Power is the rate of expending or absorbing energy. So energy divided by the time will give us the power. And we can find the equation for power. So this is the definition for power. And if you times this one, P is equals to dW over dt. If you times both dQ over dQ, we are not doing anything to the equation, we just multiply by dQ and divide by dQ. So we can rearrange this and we can say dW over dQ times dQ over dt. I just put this one here and move that one there. So this part we already know. This is the voltage and this is the current. So we can say power is equals to V times I. So this is the equation for power, and also we can use the Ohm's law here. V is equals to IR, and we can substitute V. So we can say power is equals to I squared R. And also if you want to get rid of the I, then you can rearrange this. I is equals to V over R, and you can substitute that part here. Then we can write power is equals to V squared over R. So these are the three equations that we are going to use. So power in terms of voltage and resistance, power in terms of voltage and the current, and power in terms of current and the resistance. Let's do an example. If the voltage across 25 volt bulb is 120 volts, what is its resistance? So we know the power, we know the voltage, and they're asking us to find the resistance. So we can use the equations that we had before. So P is equals to VI, or else we said that we can replace the I is equals to V over R. So we can say V squared over R is P. So we can find the resistance, which is equals to V squared over P. So V is 120 squared divided by 25. So we can find the resistance in ohms. I forgot to tell you the power in the previous equation is measured in watts. And we already know the voltage is volts, current is amps, and resistance is ohms. So we found the resistance, which is 120 squared divided by 25. So that is 576 ohms. So resistance is equals to 576 ohms. So that's the answer for this question. We also can find the current. If we find the current, we can find the current as voltage divided by the resistance. So voltage is 576 and the voltage is 25 and the resistance is 576. So we get the current as 0.208 amps. Now let's see what we have in electric circuit. So a branch represents a single element such as a voltage source or a resistor. So you can see, if you simplify this circuit given here, you can simplify it like this. So these ones are branches. So we have 1, 2, 3, 4, 5 branches here. So any element which contains a voltage source or a resistor or a current source, we consider it as a branch. A node is a point of connection between two or more branches. So you can see here we have one node, 2, 3 nodes. And a loop is any closed path in a circuit. So we can see here one loop, 2, 3. And also we can consider this also as a loop. This is a loop, and this is a loop, and this is a loop. So they also loop. So we have more than 3 loops here. When we talk about the meshes, mesh and a loop, I will explain you the difference between a loop and a mesh. Loop can be any closed path. So here we can have 1 loop, 2, 3, and also we can consider this as a loop, this as a loop. And also we can consider this whole thing as a loop as well. So we have 1, 2, 3, 4, 5, 6 loops altogether. So we can say here we have 6 loops. Actually, these 3, if we only consider these 3, that will be the meshes. When we come to that part, when we are learning the meshes, I will explain you what is a mesh. And loop can be any closed path, and we have 6 loops in this circuit. Now let's look at the circuit elements. In a circuit, we can have active elements and also we can have passive elements. Active elements are supplying energy. So there can be voltage sources and also current sources. So these ones are voltage sources. So you can see a positive and a negative sign, and the current is going out from the positive side when it is supplying energy. There can be situations where a battery is in a charging mode. In that situation, the current is coming into the positive side. We will learn those later on. For the time being, when we consider a voltage source, it is supplying energy and the current is going out, and voltage source is represented by these two diagrams. The difference between these two are one has a circle and the other one has a diamond shape. So this one is an independent voltage source. It is not depending on anything else and it is supplying a constant voltage. And this one is a dependent source. That voltage is dependent on something else. It can be dependent on a resistor or a voltage or a current. So that is a dependent source. Similarly, for the current source, we have these two symbols, and you can see an arrow. So the current is going out from towards that arrow side. And again, here we have independent current source and also dependent current source. So when we do questions, you will understand the difference between this independent and dependent, and depending on what sources we have, the way that we do the calculations will be different. And when we look at the passive elements, we can have resistors. At the very beginning, we will have only resistors in our circuits, but when we go further, we will look at this inductors and capacitors. So they are passive elements. They use energy supplied by a voltage source or a current source. But when we look at inductors and capacitors, we can charge them. They store energy. Inductor is stored energy in a magnetic field, and the capacitor is stored energy in a electric field, and they can charge and they can supply energy as well. But don't worry about these two for the time being. We will be only looking at the resistors as passive elements, and when it comes to those topics for inductors and capacitors, we will learn more about these two. Let's do an example. So in this one, obtain the voltage V in the branch shown in the figure for I2 is equals to 1 amp. So here you can see we have 10 volts voltage source. It is an independent voltage source, and here we have another dependent voltage source. So how we recognize whether it is dependent or independent? By looking at the symbol. So circle is for independent and this diamond shape is for dependent. So this 10 is not changing, but the voltage of the dependent source is 15 times I2. So this one is 15 volts. They are asking us to find the voltage in the branch, this. So you can say both are in the same direction. So negative, negative, at the bottom and positive at the top. So we can say the total voltage here, negative side and positive side, this will be 25 volts. So we need to look at the sign where you have the positive and negative, because depending on that, this total voltage will be different. For example, if we say, just let's say, in case if this is our positive side and if this is our negative side, you can say this 10 and 15. 15 is bigger than the 10. So our if you consider this whole branch, you have to say the voltage is negative this side, positive net voltage is negative up and positive down, and it is 5 volts, because this is 10 in the opposite side. You can see these signs, plus and minus signs, are different. So depending on that, the net voltage across 2 points will be different. We always measure the voltage across 2 points and current along the circuit. So we need to know this stuff as well. Let's look at the law of conservation of energy. So it says energy can neither be created nor destroyed. So here we have a voltage source which supply energy, and we have resistors, 3 resistors, and they are consuming energy. So whatever the energy supplied by the voltage source should be consumed by the 3 resistors. So we can find the power in these different elements, and they should be equal. So that's what the law of conservation of energy says. Resistors can be in different ways in a circuit. So if the resistors are connected like this, so you can see these 3 bulbs connected in a line, so we call the resistors are in series. So when the resistors are in series, you can see all 3 resistors in this example is having the same current. So when the resistors are in series, we have same current across the resistors. But if you look at the voltages, I told you voltage is measured between 2 points. The voltage across the resistor 1, voltage across the resistor 2, and the voltage across the resistor 3 will be different. So in series connection of resistors, the current will be the same, but the voltage is splitted. The total voltage of the voltage source is splitted between the 3 resistors. When you add all three voltages, that is equal to the voltage supplied by the voltage source. Now let's look at the parallel connection of resistors. So here you can see the parallel connection of resistors. So in this case, you can see the voltage across the 3 resistors are the same, but the current is splitting. So when the current comes to this point, and it is splitted between the 3 resistors. So you can see in a parallel connection of resistors, we have the same voltage across the resistors, but we have different current. Now let's see how to simplify the resistors when they are in series and parallel. So you can see in this circuit we have 3 resistors in series. We can simplify it to a single resistor by just adding these 3 together. So when the resistors are in series, we can add them together, and we can say the equivalent resistance is the sum of the 3 resistors. So we can simplify the circuit to a single resistor. Similarly, when you have resistors in parallel, we can convert it to a single resistor, but the equation is different this time. So we can say 1 over the equivalent resistance is equals to 1 over the R1, 1 over R2, and 1 over R3. So we will be able to find the equivalent resistance when the resistors are in series and parallel using these 2 equations. In most of our circuits, we have 2 resistors. So when we have 2 resistors in parallel, we can use a simplified version of the equation. So we know that 1 over the equivalent resistance is equals to 1 over R1 plus 1 over R2. So we can simplify this. The common denominator will be R1, R2, and we can say R2 plus R1. So this is equals to 1 over the REQ. Now if you make it upside down to find the REQ, that will be R1 times R2 divided by R1 plus R2. So we will be using this frequently when we do analyze circuits. Now let's do an example. Here we have many resistors together. Some are series, parallel, so we have to simplify it to a single resistor. So you can see these two are in parallel. How do we know that? Because the current is splitting, the voltage is the same. We can't say these two are in parallel. These two are in parallel because you can see that if they are connected like this, you can say they are in parallel. But here you have something here, this part. So you can't say these two are in parallel. But you can say 6 and 6 are in parallel. So when they are in parallel, you can convert it to a single resistor. That will be R1 times the previous equation. I hope you remember that. So 6 times 6 divided by 6 plus 6, which is 3. So normally when you have equal resistance, when they are in parallel, you can have the half of it. When you have two equal resistors, when you combine them, when they are in parallel, and when you combine it, it will be the half of the resistance. So that is 3 ohms. So we can now simplify the circuit. So we have all these as they are. We haven't done anything with this. So we have 3 ohms and another 5 ohms. So we simplified this part. So this 6 and 6 now is 3 ohms. Now if you look at this circuit, all 3 resistors are in series. How do we know that? They all have the same current. They don't have anything in between. So they have the same current. So we can add them together. So that will be 6, 11. So we can say 11 ohms and we have our voltage source. So this circuit can be simplified to this one, considering the series and parallel connections of resistors.